The last one was a little bit about order of operations, and I leapt into the abstract here a bit to work out this solution, where I suggest you need to show at least one step of working, because I'm never quite convinced unless I see it for myself. I'm a bit old school like that. And where do you think some issues might happen here for learners? Well, they leave a bracket out and it mucks it all up. Now, I know some folk might have not seen this for a little while, but remember, these folks were working on things like this previous to these tasks. Okay, so as I said to you, when I went around, we had these discussions, and what was coming back to me was I was getting to think that, yeah, they're understanding this pretty well. Then came the recording. I took their bits and pieces in. What did they do? Is the answer correct? Yeah. And this is what I'm saying. The oral solution, where people naturally take pauses, is somehow transmitted by them to throw equals at it for pauses. It seems to me when I started reading their work. Learner B is a bit like that English sentence, long sentence, the never-ending sentence. Have a look at some others. Second one. I know what they're trying to do here. That's the thing. I know what they're trying to do, but to maintain the integrity of their spoken answer, I think also there's a legacy within some maths learners, adult ones, that they still want to please you to get, because this is what they think you want to see. And perhaps the use of the calculator, as you pointed out, is there. They know that they have to have some sort of residual partitioning going on, and I'll use that, work that out, put a little piece of partitioning and get on to the next step. There's a lot of stuff there I like, but there's things there, I look at it and think, you got there. The area one, some of them, this was a bit strange. One or two had an argument that there was nothing wrong with the original. And the third person in the group had a devil's job trying to convince them that there was 4 multiplying bits going on there. And look what learner H did. What else can you see there with learner H? They were covering both bases with the unit. Which shows me they didn't quite get the understanding behind units as well. So there was another issue that came out of me, because here I was thinking, we'd done some stuff on square metres, obviously not well established with this person. Okay, the order of operations. Earnest attempts to apply partitioning strategies. Learner J. They divided the 2 into the 16 and got 8. And then this was remarkable. I'm not quite sure why they divided the 28 and the 14. Perhaps they've forgotten to take that out. Or, I often suspect there's an element of haste about it as well. People chase an answer along, and in their haste they've forgotten what they've written previously. A lot of learners see or don't understand the equal sign, which surprised me. And maybe I shouldn't be surprised by that. Now, Godfrey and Thomas have done a fair bit of work from the University of Auckland. They've done some stuff where they interviewed students at year 10, 29 year 10 students, and they did some work on equations and just gave these kids some equations to look at and say, what's an equation, what's not? Then they got some year 13 students, 76 of them, and asked them similar questions with, again, a sample of equations, and asked them to explain what an equation is and what isn't. A variety of answers came through. And then they asked some first-year university students similar questions, but with a bit more grunt behind it. Now, some of the students were in engineering science programs, so there was an expected background of some sort of calculus behind them, and some were in food science. But out of that, there is still a degree of not so much misunderstanding, but interpretations behind what an equation is and how equals is used is not a simple thing. It's not a simple thing. So, they basically say they need to look at relating what the parts of an equation might be, seeking equivalence, among other things. We need to deliberately work around what they think or what we think is obvious. If we don't address it while we're doing things like this or other bits and pieces, then that transfers onto the algebraic thinking. Now, not like everyone's going to be doing algebra for engineering or for other purposes, but the mission is, if we don't address it when we get a chance to talk about partitioning, then it's never going to sink in to some learners, even though it's obvious to us. Coming back to the start when we had our English sentence, we often pause before the next part kicks in, so as to invite our audience to somehow anticipate that there's a new step being introduced. When I went around the room and went to the different groups, that's precisely what was happening. But when it came through on the paper, dear old equals symbol in the way of a then or the pause. Not for everybody, but for this. And I was thinking about it later. How can we get around this?